to True Projects. In this video, we are going to discuss about the project title, which is Sentiment Analysis of Customers' Reviews using a hybrid evolutionary SVM based approach in an imbalanced data distribution. This project addresses the need for businesses to understand customer attitudes. Customer evaluations are an important source of feedback, but assessing them can be difficult owing to the uneven distribution of the data. This project intends to give a robust solution by combining multiple machine learning models such as SVM, random forest, and logistic regression. It tackles the challenge of properly identifying feelings in customer evaluations, which is necessary for a business to make informed decisions and boost customer happiness. The goal of the project is to perform sentiment analysis on customer reviews in an uneven data distribution situation using a hybrid machine learning strategy that includes SVM, random forest, and logistic regression. These algorithms are chosen for their ability to categorize feelings and provide business with important information from customer reviews. The project hybrid approach seeks to improve accuracy and predictive power, assisting business in making informed decisions, improving their goods or services, and ultimately increasing consumer happiness, which is satisfaction. This project addresses the need for exact sentiment analysis and provides a comprehensive solution for efficiently utilizing the wealth of the consumer feedback data. These are the requirements needed for execution of the project. In hardware requirements, operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. In software, we need Anaconda 3 and Visual Studio Community version. These are the design modules in the flow of work for implementing the project. The first one is importing the packages. In this module, we import essential Python libraries which are Pandas for data manipulation, NLTK for natural language processing tasks, scikit-learn for machine learning algorithms, NumPy for numerical operations, and Seaborn for data visualization. Second one is exploring the dataset. In this module, we load and explore the dataset. This involves loading the data into Pandas data frame, checking its structure, inspecting its columns, and gaining an initial understanding of the dataset's content and format. Third one is visualization. In this module is dedicated to create a data visualizations using Seaborn or other plotting libraries. Visualizations helps in understanding the data distribution, relationships, and patterns. Fourth module is data processing. This step involves several subtasks which are tokenizing the words, which means splitting the text data into individual words or tokens, removing punctuations, which means eliminating punctuation marks from the text data. And the other one is removing stop words, removing common words, example the, and, is, that may not provide valuable information for sentiment analysis. And the last part of that is lemmatizing words, reducing words to their base root or root form, which means running to run, stemming to stem. Next one is feature extraction. In this module, feature extraction is the process of transforming text data into numerical features that machine learning algorithms can understand. Techniques like TF-IDF or count vectorization are commonly used here. The next module is vectorizer text. Here, this step involves converting the pre-processed text data into numerical vectors using the chosen vectorization technique, which is TF-IDF or count vectorization. The seventh one is splitting the data into train and test. The data set is divided into two parts, which are training set and testing set. The training set is used to train machine learning models, while the test set is used to evaluate their performance. Coming to the module which is building the model. In this module, we implement various machine learning algorithms. In that, the first one is SVM algorithm. SVM is a supervised machine learning algorithm used for classification and regression tasks, which is called as support vector machine. It aims to find a hyperplane that best separates data points of different classes in a way that maximizes the margin between the classes. SVM is used in this project for its ability to effectively classify sentiment in customer reviews. It helps to create a clear boundary between positive and negative sentiments, making it a valuable tool for sentiment analysis. Next algorithm is XGBoost, which is extreme gradient boosting. It is a gradient boosting algorithm known for its high performance. It builds an ensemble of decision trees and optimizes them using gradient descent. XGBoost is chosen for its superior predictive accuracy. It is employed to enhance the project's ability to classify sentiment accurately and provide robust results. Next algorithm is decision tree. Decision tree is a tree-like structure used for the classification and regression tasks. It breaks down a dataset into smaller subsets based on various attributes, making decisions at each node to classify the data. Decision trees are used to capture non-linear relationships in customer reviews, enabling the project to extract meaningful features for sentiment analysis. The fourth algorithm is random forest. Random forest is an ensembling learning method that combines multiple decision trees. It mitigates overfitting, improving accuracy by averaging the results of individual trees. Random forest is employed to enhance the accuracy and robustness of sentiment analysis by aggregating the predictions of multiple decision trees. The next algorithm is naive Bayes. Naive Bayes is a probabilistic classification algorithm based on Bayes' theorem. It assumes that features are conditionally independent, which simplifies the calculations. Naive Bayes is chosen for its simplicity and speed. It efficiently classifies sentiment in customer reviews, contributing to the project's overall performance. Next one is K nearest neighbor, which is KNN. KNN is a simple classification algorithm that assigns an object's class based on their majority class among its K nearest neighbor in the feature space. KNN is used for its straightforward implementation. It helps the project classify sentiment based on the proximity of customer reviews in the feature space. Next algorithm is logistic regression. Logistic regression is a linear classification algorithm used for binary and multi-class classification tasks. It models the probability of an instance belonging to a particular class. Logistic regression provides a linear decision boundary for sentiment classification, making it a useful tool in the project's ensemble methods and baseline models. The next algorithm is voting classifier with logistic regression and random forest. A voting classifier combines the predictions of multiple machine learning models. In this project, it combines the predictions of logistic regression and random forest. The voting classifier leverages the strengths of both logistic regression and random forest to improve sentiment analysis accuracy. The next one is PSO SVM with SMOT. PSO is particle swarm optimization, SVM is support vector machine learning, and the SMOT is synthetic minority oversampling technique. PSO is a swarm intelligence optimization technique and optimizes SVM hyperparameters. SMOT is an oversampling technique for handling the imbalanced data. This combination aims to enhance the performance of SVM, which is support vector machine, particularly in addressing imbalanced data, which is crucial for accurate sentiment analysis. The last algorithm is ADA-SYN and SVM. ADA-SYN is adaptive synthetic sampling with support vector machine. ADA-SYN is an oversampling technique that adaptively generates synthetic samples for minority classes. It is combined with the SVM for classification. ADA-SYN and SVM are employed to address the challenge of imbalanced data and improve SVM's performance in sentiment classification. Coming to the next module, which is training the model. This step involves training each machine learning model using the training data. The next one is building the model. Here we will build all the models. The next module is Flask framework with SQLite for sign-up and sign-in. In this module, we integrate the Flask web framework with the SQLite database to create a user authentication system, allowing users to sign up and sign in. Next one is user gives input. In this module, it involves collecting user input, likely in the form of text data. 13th module is the given input is pre-processed for prediction. Similar to the data pre-processing, this step pre-processes the user input for sentiment analysis. Next module is training model is used for the prediction. This pre-processed user input is passed through the trained machine learning models to predict the sentiment. The last module, which is final outcome, is displayed through front end. The sentiment analysis results are displayed on the front end of the application, allowing users to see the sentiment of the input text, which is positive or negative or sadness. This is the comparison graph of the project. Here on the x-axis we have the accuracy scores of the algorithms, and on y-axis we have the algorithm names. Here we have the algorithm's accuracy scores. For execution, we need to open the code folder. This is the code folder of the project, and this is the static folder. This folder consists of the files related to the CSS, JavaScript and Bootstrap files. This is the templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. And this is app.py file. This py file contains the information related to the front-end logic. It includes code written in the Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML templates. And this is the model file which contains the algorithm information which will be loaded into the project code during runtime. And this is the notebook.ipynb file. This is a Jupyter notebook file which contains a combination of codes, graphs, and outputs all in one place. It allows users to write and execute code in individual cells. This is the signup.db file. This file is the database file used to store the information. So now we need to copy the path which is displayed in the file explorer. Now we will open the Anaconda prompt. Here we will use the cd command followed by the space and paste the path which is copied in the file explorer and click on enter. This will change the current directory to the file explorer directory. Now here we will give the python space app.py and click on enter. This will compile the app.py file using the command which is python space app.py in the Anaconda prompt. This command will execute the Python script and perform a runtime check for any syntax errors or logical issues. After running the app.py file, the Flask framework will host the application locally at the default address which is this one and the port number which is this one, unless configured differently. So now we will copy this link and paste it in any browser. I will paste it in the Google Chrome and click on enter. So this link has redirected to the home page which is displayed in the browser, and this front end is built by using the Flask framework. Now we need to click on sign up. If we are registering newly, we need to fill all these details. I have already registered, so directly I will click on sign in. Here I need to give the username and the password. Now I will click on login. So this has redirected to the home page, and here is the enter your text message, which means in this text box we need to give any message. For that it will predict whether the sentiment is sad, positive or negative. So here I will give the text. So here I have given the message. Now I will click on predict. Here for this particular message it has predicted that the text type is positive. Now we will try with the other message and see what will it predict. So here I have given this message and now I will click on predict. So for this message it has predicted that the text type is positive. In this way, if we give any message, the web application will predict that message is positive or negative. Now we will sign out. The project has successfully addressed the challenge of sentiment analysis in the customer reviews. Project achieved excellent sentiment classification accuracy by using a hybrid strategy that includes SVM, random forest, logistic regression, and oversampling approaches such as broadlines mode and ADA SYN. The voting classifier and LDA topic modeling enhanced our analysis capabilities. This project presents a critical solution for firms wishing to reliably extract important insights from the client feedback, which is customer reviews, hence enhancing customer satisfaction and decision-making process.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.